All right, so this is week 4 of Psych 3280, Neural-Based Consciousness. And today I'm going to introduce the visual system. Okay, recap of the week 3. So first, we looked at the studies of the brain lesion patients. And then we learned that these type of the studies can tell us what consciousness is and is not and can be. And the phenomenology brain linked data that any theories of consciousness needs to explain are offered by this type of the case studies, especially for the ones that are very strong and also detailed. Okay, and in particular, we looked at the locked-in syndrome and cerebellar agenesis, the people who was born without cerebellum, and the bilateral damages in the prefrontal cortex. And then we learned that the conscious experience of the patient can dissociate from externally observable behaviors. Like in the case of the locked-in, they cannot move, but conscious experience of the patient was completely intact. And in fact, that person who had that locked-in syndrome in the movie was even able to write a novel, highly cognitive act and also conscious act that was depicted in this Bell and the Butterfly movie. Okay. And then secondly, we looked at the architecture of the brain areas that matters or not. And these reveal that it is not only the number of the neurons, but it's important thing to consider is how it's structured. So cerebellum in particular has 4 times more neurons than the cerebellar cortex and thalamus together. However, because of their parallel architecture, most likely it doesn't contribute to consciousness. And finally, executive or social functions that sounds like a really complicated function, and indeed it is complicated, can be impaired with the intact conscious seeing, hearing, and feeling. And this is the case of the bilateral prefrontal cortical patient, including Phineas Gage. Those people who are damaged in the prefrontal cortex can be impaired in executive functions and so on. So as a person, they look completely different person, unreliable or liar and so on. But still, they seem to be very, very, conscious in every, ways. All right, and then the second part of the week 3 focused on the what happens in the case where the people or monkey lost posterior visual areas here, right above the cerebellum. And then they turned out that to report to loss of visual consciousness. It's very specific on the visual consciousness. And however, interestingly, the case of the blindsight is that patient and monkeys can move around, especially when it's forced. However, they demonstrate above chance performance. The blind patient, first report not seeing, right? As I said in the first line, but they can demonstrate behavior, possibility, performance. And this fact led to a lot of questions. And first of all, we want to know what it's like to feel not seeing, but can do something like blind sight. Can we reproduce it in a normal subject? And secondly, can we simulate blind sight in normal observers? And then how can we discriminate conscious versus non-conscious behaviors by observing or analyzing the data carefully? Can we actually discriminate these two? That's the question. And then to understand all of these, we need to start to understand that what visual inputs to the brain is like. Okay, so given these learning objectives for week 4 is that first, what is like to experience masked stimuli. It's one way to make the stimulus unconscious to the experiencing subject. And then second, what is the neural responses induced by this masked stimuli? Third, what can we do with the masked stimuli? Can we behave based on the masked stimuli and so on. And further on, fourth, can we simulate blindsight-like behaviors using monkey models? And then how can we discriminate non-conscious from conscious behaviors using a concept called metacognition? I'll explain that. And then finally, what are the properties of the visual inputs to the brain? What is the structure of the eye and how does it shape our conscious vision? And from this week on, I mean, I've been doing this over the last 3 weeks, but it becomes even more so that the lecture contents will shift from psychology, neuroscience, phenomenological demonstration, and a little bit of the statistical or mathematics, all intermixed, and that's necessary to understand this, interdisciplinary concept and topic of consciousness. And this kind of intermixed and also complex kind of subject is called teaching, is called the active learning style, and it's supposed to improve your learning ability and critical thinking. So hope that you like it. And in terms of the reading, I recommend chapter 3 of the Quest for Consciousness for both this week and next week.